So after knowing how to solve the questions, you may wonder what is exactly this transfer function. Okay, so in a few videos ago, we actually described that the low pass filter is A over S plus A. Alright, so in this case, we are supposed looking at a S plus A divided by 0.1 S plus A. Alright, where A is equals to 1. So we can just write down as A is equals to 1. And what is A? A is your cutoff frequency. Okay, and then since we also know that S is equals to J omega. Alright, maybe, what am I doing? Why is it here? Wait, hold on. Right. Since you know that S is equals to J omega, maybe I should write it as capital omega because we are dealing with analog. Alright, I'm going to use the analog to prove to you what transfer function will this be. Alright, and therefore this will be S plus, I'll have J omega plus A over 0.1 omega plus A. Okay, so what can we deduce on this? Alright, but before that, I'll just also square them because I'm only taking in absolute value of frequencies. Okay, actually this also is J. Alright, so if I were to square everything, I'll have J omega square plus A square. Okay, this numerator one, 0.1 omega J square plus A square. Okay, so let me show you something. Alright, if you still remember just now in the low pass filter, we said that when A is equals to omega, alright, we'll have a half power, and then 10 times log half is equals to minus 3 dB. Alright, so over here we're also going to do the same thing. If A is equals to omega, what would we have? Alright, so we know that A is equals to 1. So if A is equals to omega, which is equals to 1 in this case, alright, now just simply sub in lah. So I have a 1 square plus A is actually what? Is 1, right? So therefore I'll just have 1 square also. Okay, divided by 0.1. My omega is 1, right? So therefore I'll just leave it as 1. 0.1 times 1 is 0.1 square plus A square over here is 1 also, right? So it's 1 square. Okay, and you may wonder how come my J is gone. Okay, in fact I also don't know a bit, but yeah, come to think about it, just ignore that first, because in the low pass filter I also do that, and then it's what they do lah. So in the end they found out it's minus 3 dB, so they actually ignore the J already. You may take it as J, if J square, then actually it will become equals to minus 1, right? However, over here I actually didn't have any minus 1. Okay, so this is something that let's leave it and think, or maybe, yeah, I don't think so. Yeah, but anyway, let's just take it as this thing. Alright, let's ignore the J. Alright, in some of the sense that we are taking absolute value of whatever the J is. Alright, I don't know lah. Okay, just leave it to think about it. But at the end of the day, you have 1 plus 1 is equals to 2, because 1 square plus 1 square is equals to 2. And then 0.1 square, you'll have 0.01 plus 1, you'll have 2 over 1.01, right? So if you solve for it, you'll have equals to 1.98. Alright, so therefore let's just find the decibel. I'll just take 10 log 1.98. Later on you'll see that it's actually 3 dB. Alright, 3 dB tells you what? In the low pass, minus 3 dB is that it's going downwards, right? So this thing over here is minus 3 dB. So if it's a plus 3 dB, most likely you can think of as a high pass filter. Alright, there will be a plus 3 dB over here at this cutoff frequency A. Okay, so in order to further prove to you that it's a high pass filter and is also an amplifier high pass. Okay, and why do we say that it's an amplifier high pass? And this is why, let's carry on with things. Okay, so for example, if I were to just erase all these things, since we already proved to you that it's a 3 dB system already. Okay, let's just use the same definitions all over here again. Alright, next, if omega is larger than A, alright, so A is equals to 1. So for example, if omega is 3, for example, so 3 larger than 1, right? So this is sub in as my omega also. So therefore, what do we have? Alright. So over here at when omega is equal to 3, so it's 3 square plus a square is actually a is 1, right? So I have 1 square divided by 0.1 times 3, right? Because our omega is 3, right? We have proved to you that. And then plus 1 square a is equals to 1. Alright, so what I have is 9 plus 1 divided by 0.3 plus 2, which is 10 over 2.3. Alright, so if you think about it now, the output will be somewhat 4.34. Alright, so I'll just write it as 4.34. Okay, now if happen, I change the color, maybe a green color. If happen that my omega is smaller than a, such that a is 1, my omega is perhaps 0.1, okay, which is smaller than a, what will I have? Okay, so I'll just simply remove this thing again. Alright, I'll use the same formula. So what do I have? My omega in this case is now it's 0.1, right? So therefore I will have 0.1 square plus a is equals to 1, right? So just 1 square, okay, divided by 0.1 times 0.1, because my omega is 0.1, right? My input frequency, so to speak. If you don't know what is omega, omega is our input frequency. Okay, so omega is equals to whatever your frequency. Okay, but because we want to differentiate, this is analog frequency, this is digital frequency, this is why we often show in our text as capital or small capital. Alright, so please be careful of that. But they are the same frequency. Frequency is just frequency, but they just want to indicate that it's analog or digital, that's all. So let's just continue. So therefore 0.1 square is actually 0.01 plus 1 divided by 0.1 times 0.1 is 0.01, right, plus 1. So what do we have? As you can see, sorry, this is square. Okay, so this thing over here has to be squared. So 0.01 square is really a very small number. I think it's sorry, where am I? Yeah, it's 0.0001. Okay, so if I have to add them out together, I'll have 1.01 divided by 1.0001. If you were to think about it, what would it be? Approximately 1.001, something like that, I think. Yeah, so 1.01. Okay, so what can you deduce from this understanding? Okay, at the low frequency, alright, at a low frequency, you are 1.01. Okay, so you're always at a magnitude of 1. So this so-called filter, so to speak, this transfer function allows any signal to pass through it. So your signal doesn't actually goes down, it doesn't start from 0, it starts from 1. Right, so you pass through signal if you have a low frequency. Alright, so if you are low frequency, you just pass through whatever signal coming from other sides. Alright, some other stuff. So when you come over here, it just doesn't change anything. It just equals to 1, and then you output as whatever thing that is over this side. So for example, if you have a certain block diagram, this is our amplifier. Alright, you may have some music, and then this music will go through this amplifier. If you're low frequency, alright, then if it's low frequency, then the amplifier will just output the volume of your particular music. Alright, so if it's a high frequency, alright, then your music will be amplified and you'll have a larger volume, so to speak. Alright, I hope that is pretty clear. So therefore, in such of the case that happens, alright, at this case it's a low frequency. So at low frequency, it's 1 all the way throughout until you reach your cutoff frequency, which is A, which is equals to 1 in this case. Alright, so therefore when you reach your particular frequency at 1, if omega is equals to 1, your frequency is equals to 1. So this whole thing is actually frequency, so to speak, and this one is amplitude. Okay, so this thing over here will be your 3 dB. Okay, and then you go all the way up, bam, alright, so 4.34. So if you increase your frequency, alright, above your cutoff frequency, then you're gonna bam, go amplify, alright. So therefore, as you can see, this point over, for example, is your 4.34. Corresponding frequency is 3, right, which is, we have shown you your omega is 3 over here. So as you can see, this is clearly a high pass amplifier, alright, and also such that it helps you to, it doesn't bring your signal down, alright. So you continue to pass through your signal up till when you reach your cutoff frequency, you can amplify your signal, alright. So this is the thing, alright, you didn't change your signal at all. It's always 1 times your whatever signal that comes in until you increase your frequency, then bam, it goes up and things like that. Alright, so I hope that this gives you a pretty clear understanding of how to look at whatever transfer function you are doing, or at least you know what is the purpose of the transfer function, so to speak. Alright, so therefore I'll leave you to that.